Hello. Right. Okay, so can you hear me loud and clear? Okay, perfect. Thank you. All right. So this meeting is recorded so that everybody can watch it at a later time. And so yes. Why am I not the main speaker? Just a second. Sorting out some technical stuff. Okay. And okay. Now I should be in the spotlight for everyone. Hello, welcome to the second webinar. And today we're going to go through some problems on vectors, of course. So this is for the first assignment. And let's jump into it. So I will go through 8 similar problems, similar to those the assignment. Some of them are scarily similar, but yeah, I couldn't find anything close, but not so close. So one of the problems would be very, very similar. Okay, so I'll share my screen. And if you do not see my screen, please type something in the chat so I know. If you see it, then everything's fine. Okay, I'll just open the chat. Okay. Which way does it go? Okay. Right, so the first question, this is from the physics admission test 2007. So this is an Oxford question. And it goes like this. A pilot plans to fly an airplane from his base to another airport 300 kilometers due north. His airplane can travel at a speed of 170 kilometers per hour and relative to the hour. He sets off at 9 a.m. and aims his airplane due north, calculate his estimated time of arrival. Time assuming there is no wind. Well, the first question seems very simple, and it is absolutely, by all means. The only way you can go wrong is just getting the time wrong, because they're asking for the estimated time of arrival. So if we draw a quick diagram, so this is his flight path, which is 300 kilometers. 300 kilometers, and the distance. So his speed is 170. So very simple. We divide the distance by the speed, and we get 1.7647 hours, which equates to approximately 1 hour 46 minutes. Now, they're not specifying how accurate you should give your result, but as a rule of thumb, 3 significant figures. That's the first rule that you should be using. But also common sense, because you wouldn't give the arrival of an airplane correct to seconds. Yeah. So maybe it would be reasonable even to give the arrival correct to 10 minutes, but 1 minute is absolutely fine. So you just try to put yourself in a real situation, like what would you say, for example, as a pilot to the ground control. So you would say the estimated time of arrival, therefore, because he takes off at 9, his ETA is 10:46. 10:46. So very straightforward problem just to get you fired up, basically. But then there's the second part is much more interesting. So it says after flying for 1 hour, he discovers that he's only 153 kilometers from his starting point. So for question B, I'm going to draw a diagram. So this was his plan. He was planning to fly straight, but there was wind. So, and he's traveled along a line at a bearing 0.010. So therefore, his plane. Okay. Therefore, his actual flight path went like this. Okay. And this is 170 kilometers because he has been flying for 1 hour. So we know that he has traveled 170 kilometers. Oh, sorry, it's 153 kilometers. Oh, I got this one wrong. Okay, 153 kilometers, and his bearing is so okay. So this is the distance he has traveled. Now we know that he was pointing the airplane due north. So his airspeed is 170. So his airspeed is 170 kilometers per hour. So this is his airspeed, and we'll use the triangle rule to add triangles. So we know that we know that there was wind. Basically, we need to write down that the displacement, well, the velocity relative to the ground is equal to velocity with respect to the air plus the velocity of the wind. Velocity of the wind. This is equation in vectors, so these are all vectors, and we need to use the triangle rule here. So what we do know is we know that his this is his displacement relative to the ground. Yeah, so we can technically we can rewrite this. So let's do it. If we multiply this by t, I'm making it slightly more complicated. If we multiply this by t, we get displacement, because displacement is velocity times time. So we can say the displacement relative to the ground is equal to the displacement relative to the air plus the displacement relative to the displacement caused by the wind. Displacement caused by the wind. I was looking for the phrase here. So displacement caused by the wind, and we know that this is the displacement relative to the air. So that's what the pilot wanted to achieve. But then there was wind, and the pilot ended up flying like this. I'm exaggerating the angle slightly. Pilot ended up, so pilot wanted to fly 170, but he ended up flying only 153. And we need to find the velocity of the wind, or the displacement caused by the wind. And it's here. It's here, and this is the displacement caused by the wind. Okay, so what do we know? Well, we know it's a triangle. We know that this is 10 degrees. 10 degrees. So all we need actually is just use the cosine rule here to find the. Okay, I'm gonna say that this is I just don't want to overcomplicate it. So this is velocity relative to the air. This is velocity relative to the ground. And this is the velocity of the wind. All are vectors. Therefore, we can say that velocity of the wind squared, using the cosine rule, I'll indicate that using the cosine, using cosine rule, velocity of the wind squared is equal to 170 squared plus 153 squared minus 2 times 170 times 153 times cosine of 10 degrees. 10 degrees. You just plug this into your calculator. 70 squared plus 153 squared minus 2 times 170 times. Always make sure your calculator is in degrees. So it's 179, and so the speed of the wind is the square root of that is 32.9 kilometers per hour. Kilometers per hour. And the displacement caused by the wind is obviously 32.9 kilometers. And the speed of the wind is 32.9 kilometers. Do we need to find the direction of the wind? No, just the speed of the wind. If they were asking to calculate the direction, then you would find this angle. You would find this angle using the sine rule, for example, and give the direction relative to position. Usually we give the bearing. If we talk about the wind, we give the bearing of the wind. So, okay. Right, next question is also a physics admission test question. This is quite similar to one of the questions we had. Well, actually, yeah, one of the questions that we had. A rower wants to cross a river to a point opposite the riverbank. On the opposite bank, directly opposite from the point where she will start. The distance to cover is 100 meters, and she wants to cross it in 10 seconds. I have to say that this is a very ambitious rower, because the 100-meter world record is just over 13 seconds. Yes, let's say a very ambitious rower wants to cross a river. And so this is 100 meters. Apologies. Oh, by the way, so I forgot to share it with you. Just in case you want to follow, rather than following my screen, if you want to follow yes, the board. Are you allowed a calculator? That's a good question, because on the pad you weren't allowed to use a calculator. Well, if you're not allowed to use a calculator, you would just give the answer. If you don't have a calculator, you would say velocity is square root of 170 squared plus 153 squared, which is 523. I wouldn't even bother. I would say 170 squared plus 153 squared minus 2 times 170 times 153, which is 52,020 cosine 10. This is what you do if you don't have a calculator, because that way you show what that you know how to do it. Okay, so 100 meters, and there's the speed of the water. The water is it's a very rapid stream, 7.5 meters per second. No, previously in the pad you weren't allowed to use a calculator. 3 years ago they changed the rules, so you are. And so 7.5, that is the velocity of the water. And her plan is to travel at 10 meters per second this way. Yeah, if you're not sure why it's 10, well, it's quite straightforward. It's 100 meters she wants to make it. This is her speed relative to the ground. So this is her speed relative to the ground, which is 10. So well, speed, of, in this case, velocity relative to the ground. And we know, I have to write this down. So this is the velocity of the water. This is her velocity. Well, this is her velocity. This is her total velocity. And there's the velocity of the river. Well, we know that we have her velocity. Velocity is equal to velocity of the water plus this is her velocity relative to the ground. Okay, this is not working. I have to. This is her velocity relative to the ground, and her ground velocity is velocity of the water plus the velocity of the boat. Okay, of the boat relative to the water. And from here, we can see that velocity of the water plus the velocity of boat is equal to Vg. Ground velocity is the velocity of the boat relative to the ground. So velocity relative to the ground plus velocity of water plus velocity of the boat's velocity. Sorry, that's equals. And using the triangle rule for vectors, we can sketch that. So velocity of the water plus the velocity of the boat will equal to velocity of the ground, velocity relative to the ground. So this is a triangle rule for vectors. Okay, I'll do it slightly more realistically. So we know that the velocity of the water is like this. And we know that the velocity relative to the ground is the total of the two. So velocity of the boat must be going like this. And in order for the rower to row this way. So this is the velocity of the water. This is the velocity of the boat. And this is the ground velocity, or the resultant velocity. This is the, so Vg, G is the resultant velocity. And we know that the resultant velocity is 10, so we just need to find the velocity of the boat. Okay, and here we use Pythagoras theorem, very straightforward. So, I mean, technically, physics ends here. This is where you just start doing maths, because once you've drawn the diagram and you understood what's going on here, once you've written that, everything else is just calculating the values. So velocity of the boat, boat's own velocity. So this is how fast she needs to row. It's the square root of 10 squared plus 7.5 squared, which conveniently is 12.5 meters per second. Once again, the fastest average velocity of a boat over 100 meter run is about 8.5 meters per second. So the fastest, you use Pythagoras to find boat velocity. Yes, exactly. I am using Pythagoras. If it's not clear, let me know. And the angle. Now, the angle is what angle relative to the flowing water? Relative to the flowing water. Well, this is the boat's velocity, and this is the stream of the water. So we need to find this angle. We need to find this angle. This is vectors. This is vectors. And if you know the rule for adding vectors, it follows like this. The ground velocity is not the hypotenuse, no. Ground velocity is this side. Look, if you take this vector, velocity of the water, plus the velocity of the boat, you get a resultant vector, which is this. Sometimes the resultant vector is shorter. Yes, hypotenuse is the velocity of the rowing boat. So that's the trick here. Just trying to figure out which one is which. But this is always true for any boat in any river. So just to remember this, and this is true for airplanes. When an airplane flies, the ground velocity is equal to the velocity of the wind plus the velocity of the aircraft. Well, you just read the question. What angle relative to the flowing water? So they're asking angle to the flowing water. So they're asking for this angle, theta. It's how to find it is trig, of course. So rather than finding this angle, I'm going to find this angle. I'm going to find this angle first, and then do 180 minus that. So theta is 180 degrees minus that angle. And this angle is, because it's a right angle triangle, is the inverse tan of 10 over 7.5. Inverse tan of 10 over 7.5. So arctan of, it always does that, arctan of 10 over 7.5, which is the same as 180 degrees minus arctan of 4/3. So 4/3. Acute angles. Well, it's because of the direction of the flowing water. I mean, look, you would probably not even lose marks if you forgot to do 180 minus that. But when you are saying direction relative to the moving water, you take the angle between the direction of the water, not the opposite direction of the water, if that makes sense. Because there's a clear indication of the velocity of the speed of the water. So in this case, is approximately. This is how you would give an answer if you're not using a calculator. This is a valid answer. 180 minus tan 4/3. But because we have technology, we can calculate it to be 127 degrees. So yeah. Okay, so this is the first two questions. Now, if you look at problem 3, you will definitely recognize it. It's from here. So I'm not sure I want to do it fully because it's very, very similar. But I'll show you how to do it. So it is given that 17a minus b, the modulus of 17a minus b is equal to the modulus of 17b minus a. Show that modulus a equals modulus b. From horizontal line. Okay. So how to start with? Well, if you have an unknown vector, as you have, a is an unknown vector, well, what you can do is simply say, well, let's say that a, vector a, is a1, a2, and vector b is b1, b2, using columns here. That way, 17a minus b is equal to so 17a1 minus b1 is 17a2 minus b2, and of course 17b minus a is equal to 17b1 minus a1 17b2 minus b2 minus a minus a2. Fantastic. And then we just write down the modulus, and we know the modulus of a vector is the x coordinate plus the y coordinate square. And also we can use to simplify things, well, we can say that if the moduli are equal, that means the squares are also equal. So if you square both sides, it's still the same. That will make life a tiny bit easier. So basically what you do is you write down 17a1 minus b1 squared plus 17a2 minus b2 squared. It's not a particularly sophisticated problem. It's just you just need to do it very carefully. And I'm just going to do the short way. 17 b1 minus a1 17 b2 minus a2. Yes. And all you need now is to expand. And when you expand, you will see when you expand and you take them to either sides. So as an exercise, do the expanding yourself. Expand and simplify. Simplify, you shouldn't have any problems here. You get something in the lines of 288a1 squared plus 288a sub 2 squared equals the same thing, but with b's. b1 squared and b2 squared, and you can divide this by 288. Divide this by 288. And you get this, and this is exactly, so this is a1 squared plus a2 squared. That's exactly the modulus of a well, technically squared, and equal to, well, we don't have to do this. What we can do is we can say, well, I'm going to take the square root of both sides. Because both sides are positive, we are allowed to take square roots if both sides are positive. Square root of that. Square root of that. All right. Square root of that is equal to square root of that. Okay, and but the square root of a1 squared plus a2 squared is literally the modulus of a. Modulus of a equal to the modulus of b. Modulus of b. That's it. That's it for question 3. So you will find a very similar question in your assignment. Any questions? Any questions here? So not too many. Okay, moving on. V and W are sides of a parallelogram. Find the angle between the diagonals of the parallelogram. Okay, so first thing we need to establish is what are the diagonals and how to find them. And this all comes down to an accurate sketch. So let's say this is vector v. I'm not trying to draw this. I'm not even looking here. I'm just drawing arbitrary vectors. Yes, you need to use dot product here, and w. This is vector w, and it says that they are sides of a parallelogram. So you copy this side over here, and you copy this side over here. So you have a parallelogram. It says find the angle between the diagonals of a parallelogram. So let's take the diagonal of a parallelogram, the first one. And from the parallelogram rule, let's call this diagonal A. Let's call this vector A. From the parallelogram rule of adding vectors, you can say that A is V plus W. Okay, of course, vectors. Okay. When you're writing, you can just underline them. Also a simple version. So vector A, this diagonal 1 is V plus W. And let's draw a diagonal like this. It doesn't really matter which way you draw, but I'm going to use this one. And here I will have to use the triangle rule for adding vectors. Let's call this vector B. Using triangle rules, using triangle rule for vectors, we can say that vector W is equal to V plus B plus B. W is V plus B. Therefore, B is equal to W minus V. And of course, this is a vector as well. Vector. And well, we can calculate those. We can calculate vector A. Vector A is now we actually look is 3 minus 1. 3 minus 1 plus this vector. So 1, 3. Right, and this is a vector for 2. And B, of course, B, I'll write it separately. B is so it's W minus V, so 1 minus 3, so minus 2. Minus 2, and 3 minus 1, minus 2, 4. Okay, so minus 2, 4, and 4, 2. And all you need is to find the angle. You know, the angle between two vectors, the cosine theta, the angle between two vectors, so this angle, theta, because that is the angle between the diagonals. Cosine theta is equal to the modulus of A, modulus of B, Oh, sorry. What am I doing? Of course not. It's the dot product of A times B divided by the modulus of A times the modulus of B. And vectors, vector. You won't be marked down if you forget the vector sign in the working, but yeah, try to stick to it. Okay, so we'll start with finding the top bit, and the top bit, as you can see, is actually 0, because if you the dot product of A, B, so I'll just also do a clever thing here, just add a dot. Can you, if we get a low percentage, will we not get any here? Well, I'd say if we see that you're making an effort, we will give you the chance to carry on, and we'll try to. Modulus is the length of the vector. Yes, if you're making an effort and you're working, then we would, yeah, keep you on board. And so modulus is the length of a vector, and the definition of a modulus is, so if you have given a vector A with coordinates, it's all written in the assignment, A1, A2, and A3. The modulus of A is the square root of A1 squared. It's the Pythagoras theorem plus A2 squared plus A3 squared. And this is a vector, of course. And this is a vector. In 2D, you just cross out the A3. Yeah, magnitude. It is the magnitude. Modulus is and magnitude are the same thing. And modulus is the same as magnitude, is the same as length of a vector. Okay, and if you actually look at the vectors and you use the rule for the dot product, use the dot product rule, you will see that it is 4, 2 multiplied, well, no, dot minus 2, 4. Minus 2, 4. And quite clearly, this is 4 times minus 2, 4 times minus 2, plus 2 times 4, which is 0. So this thing is 0 divided by modulus A, modulus B. So you don't really need to calculate those, because whatever they are, this will be 0. This will be 0. And if cosine theta is 0, that means theta is 90 degrees. Theta is 90 degrees. Because cosine theta is 0. Yeah, it's not exactly the same thing as the modulus. Modulus of minus 4 is not exactly the same thing as modulus of a vector. definitions are slightly different. Modulus is defined as the distance from 0. Modulus of a real number is defined as the distance from 0. Modulus of a vector is defined as the length of the vector. Okay, problem 5. This problem actually was supposed to be in the assignment. We removed it because it's quite simple. But I wanted to point out some of the things about vectors, so that you don't get confused. So what are all those things? Well, we have a vector A. So let's draw a vector A. Is 4. Well, it doesn't really matter how it is. This is a vector. Okay, for simplicity, yeah, A. Sorry, this is vector A. And now we draw the axes. We draw the axis. We draw the x-axis, the y-axis, and the x-axis. Now, who said that the vector is from the origin? But if you move vector A anywhere, it's the same vector. Okay, so vectors are displacement invariant. Well, the vector doesn't change if you move it. So we can always draw a vector from the origin. Any vector can be drawn from the origin. And here, if this vector, it goes like this, you can split it into components. You can split it into components. And this vector is going to be AX. This is the projection on the x-axis. This is the projection of vector A on the x-axis. Similarly, this is the projection of vector A on the y-axis, and it is called AY. AY. And yeah, that's pretty much it. AY is also a vector. AY without a vector is actually the y coordinate of the vector. It's the projection. So AY, because A is 4i plus 3j, so it goes 4 to the right and 3 upwards, it's quite clear that AY is going to be, and AY is a vector. So it's going to be 0 minus 3. 0 minus 3. Because it's 4 minus 3j. 4 minus 3j. You can, yeah, so it's the vertical component. It's the vertical component. Vertical. You can, this is how you like it. I like columns. I always choose columns over unit vectors, just because unit vectors is harder to read for me. This is my personal preference. You can use vectors as you like them. This is the vertical component, or which is the same as minus 3j, which is the same as minus 3j. Well, technically it is a vector, minus 3j. Now, if you do A times A dot product j, and so I'm just going to write it down here. A dot product j is 4 minus 3. Yeah, 4 minus 3. Change color. 4 minus 3. Dot. J is 0, 1. By definition, we know J is 0, 1. And we use the dot product rule, and it's minus 3. Ooh, interesting. So actually, the coordinate of a vector is the dot product of the vector and the direction vector. And that's an important result. That's why I actually wanted to have this here. And this is minus 3. Why is J 0, 1? Oh, this is the definition of a unit vector in the y direction. J is this vector. This is vector J. This is vector J. It's a unit vector in the direction. And this is I. Vector I is a unit vector in the x direction. So we have I is equal to 1, 0. Not like this. 1, 0. 1, 0. J is 0, 1, 0, 1. Sometimes we have K. Sometimes we have K. Or if we're in 3D, this is 2D. 2D. This is 3D. 1, 1, 0, 0. 0, 1, 0. And we have vector K, which is 0, 0, 1. Yeah, it's by definition. I is always on J, and J is always on Y. Yeah. And you will see that it's minus 3. So the important result here is that the dot product of a vector and the unit vectors, the dot products of a vector A and the unit vectors I, J, K are the coordinates of the vector. AY. So what's the difference between AY and AY? An AY vector and AY? Well, AY is simply the component, is the component which is minus 3. Because vector A can be written as AX and AY. So it's the component. So it's also minus 3. A dot product B. Well, this is also quite straightforward. You just use the formula for the dot product. So it's giving you 4 times minus 2, 4 times minus 2, plus minus 3 times, okay, plus open bracket minus 3 times 5 times 5, and this is minus 23. Minus 23. Modulus of AY equals 3. Yes. Modulus of AY and modulus of vector AY also 3. And finally, E. Sorry, got a bit messy. Okay, E. And E. So, well, there are different ways to do it. You can expand the brackets and get something like you can expand the brackets and get 2a squared. So it's going to be 2a squared minus 6ab plus ba and minus 3b squared. But actually, you can also find the vectors first. So, you know what? I think I can do it here. I can do it here, and I'm gonna do it straightforwardly. So 2a plus b, 2a plus b is a 2a, so 4i minus 6j plus b, so minus 2i plus 5j. Combining the terms, you get 6 minus 1. Minus 1. So 2a plus b. So 2 of those plus b, 6, 1. And 3a minus 3b, a minus 3b, that will be 10 minus 18. Minus 18. Okay, would you like me to show you how I did it? Type 1 if you would like me to show it. Okay, yeah, that's fine. I will. I thought so. It's a bit messy here now. So question E. Question E. So because we know that A is 4 minus 3, and it is a vector, and B is minus 2, 5, minus 2, 5. We need to find 2a, a plus b, plus b, 2a plus b. So it's 2 times 4 minus 3 plus minus 2, 5. And this is equal to 2 times 4 minus 2, which is 6. 6 and minus 2 times minus 3 is minus 6 plus 5 is minus 1. In a similar fashion, a minus 3b. Don't forget those vector signs. Vector 3b vector. Okay, is a, which is 4 minus 3, minus 3, minus 3 times minus 3 times minus 2, 5. And you get 10, 18, minus 18. Coming back here, because 6 times 10 is 60 plus minus 1 times minus 18, which is 18. which is 78. So the scalar product. The scalar product is a scalar. I mean, it shouldn't surprise you. A scalar product is a number, whereas, so a scalar product, yeah, scalar product is a number. Straightforward. Okay. Problem 6, and this is a very physics problem. Although you don't normally do problems like this in this fashion, but I just wanted to show you the link. In physics, work is the scalar product of force and displacement. So I'm linking the scalar product in physics because they don't usually tell you that work is actually force times distance, force times displacement. And if you look at the formula for work, not the GCSE one, but the more advanced one, the work is force times distance times the cosine of the angle between them. That looks suspiciously familiar. This is actually the dot product. So work is actually the dot product of the force and the displacement. Well, we can say S. We usually use S for displacement. And displacement Fs. So S displacement and F is force. So that's the definition of work. So why not just write out the vectors? So the work done by each vector. So work done by vector F1. And so we write out the vectors. So from the diagram, it's quite, you can see that F1 is given to it's given that F1 is 10, F2 is 5. So the vector F1 F1 vector, okay, we don't, it's supposed to be like that. F1 is a vector, is as a matter of fact, it's 0 minus 10. F2 F2 as a vector is 5 0. 5 0. Because it's just the y component of A. Okay, so it's not a question for me. F2 and the displacement vector. Is the same as this vector delta r. Delta r is the change in change in the position vector, is equal to, and if you look at it, so it's 4 to the right and 2 up. 4 to the right and 2 up. So this vector is 4, 2. And now we find the work. So work 1 is equal to force times F1 times C dot F1 times the displacement, S, and that's equal to 0 minus 10 times S, which is 4.2, and that's equal to 0 times 4, 0 times 4 plus minus 10 times 2. So the answer is minus 20 joules. The work is negative. What does it mean that work is negative? If you look at so an object is moving along this vector. This is the movement of the object. Object is moving along this vector. And the force is applied here at this angle. This means that this force is actually slowing the object down. It's performing negative work on the body. It's like the brakes of a car, because you're moving forward, the brakes are pushing you backwards. So the car brakes are performing negative work. So this is what negative work means. It's reducing your kinetic energy. Reducing kinetic energy. So W2 is equal to 50 multiplied by 4.2. This is not a typical way of finding the work, but it just shows you the link. So 5 times 4 is 20 minus 0, so that's 20 joules. And you can see the force F2, in fact, is trying to increase the kinetic energy of the object by all means. But then, interestingly, W1 is minus 20, so the total work is 0 joules. And then total work is 0 joules. And then we can actually find, so R is the resultant force of the term. So R is F1 plus F2. This is the total force, resultant of the two. And it says, is it possible to guess the answer to be without doing any calculations? Well, if you look closely, you will actually, and you look at the coordinates. The coordinates of the vector R is 5 minus 10. Vector R is 5 minus 10 because R is equal to F1 plus F2. R is F1 plus F2. And yeah, so it is 5 minus 10 minus 10. And the vector R is 4, 2. So actually they are perpendicular. You can convince yourself that these are perpendicular. And we know, so this, okay, but by just looking at the diagram, you can see that the R is perpendicular to the displacement. And if you have a force which is perpendicular to the displacement, so this is a force, and this is the displacement force, and the angle between them is 90 degrees. The work done is force times distance times the angle, so it's 0. It's 0. So work is force times displacement times cosine 90, which is 0 joules. A very interesting example of this is satellites. So here, basically, because force is perpendicular to the movement, Yeah, short story. Because force is perpendicular to displacement. Force is perpendicular to displacement, so the work is 0. Force is perpendicular. Force no is perpendicular to displacement. So no work is done. Work is done. This is from definition. So definition of work. Work is force. Work is force times displacement times cosine theta, angle between them. Or you can rewrite the same thing. Work is vector F is the dot product of, like this. This is not vectors. This is, okay, just to understand, this is the modulus. This is modulus. This is modulus, and this is modulus. Yes, from vectors. This is the definition of work, the one that you're given in school. F distance times cosine. And this is another definition, which is actually the first definition. This comes from that. For no work is done. A very interesting example is satellites. So if you have a satellite orbiting a planet, so let there be a planet, and there is a satellite. So this is a satellite orbiting a planet, and the velocity of the satellite is like this. And the gravitational force, or the weight of the satellite, is like this. This is the weight of the satellite, and this is the velocity of the satellite. So velocity is 90 degrees to the force. So gravity, so weight does not do any work. That means the kinetic energy does not change. Because if weight was doing work, the kinetic energy of the satellite would increase, but the kinetic energy does not change. Therefore, yes, that's an interesting example, because this is 90 degrees, because force, work is, okay, force, I need to say F. Work is force times distance times cosine 90 in this case, because, yeah, so that's 0. Work is 0. That's an important result. It's very frequently asked in exams, so you might want to just keep that in mind. Now, F1. Yes, technically, you mean here. They do. Yeah. So this is a vector. This is a vector. This is not a vector. Yeah, so work is not a vector. So never put an arrow over work. Okay. Now, we are a bit short on time, but problem 7 is very similar to what we did before. A small airplane airspeed is 60 knots. There's a steady crosswind of 10 knots. How should the pilot direct the aircraft? So basically, if the pilot tries, so if this is the runway, so if the runway goes from north to south, if this is the runway, if the runway goes from north to south, this airplane flies like this. Then the crosswind will cause the airplane to fly like this, a crosswind. And this is not a very good idea when you're landing an airplane to fly off the track. So what needs to happen? The pilot needs to point the aircraft sideways like this, and the wind is like this. And using the parallelogram rule for adding vectors, the speed of the aircraft is going to be like this. Now, very surprisingly, this is a GCSE question. Well, it is a year 10 question from a school, but it's quite interesting. Like this is quite advanced. This is way harder than year 10 should be able to solve. I'll get back to this question if we have time. Okay, because I really want to go through the hardest question of the assignment, and it's the last one. And I've seen some of your answers already. I haven't seen correct ones yet. So a boat is crossing a fast river. The speed of the boat is 2 kilometers per hour. The speed of the river is 7. How should the driver direct the boat in order to end up? So we'll probably spend at least 15 minutes discussing this. To end up as close to the starting point as possible. Several things. One thing you really need to be comfortable with is the rules for adding vectors: the triangle rule, angle rule, and the parallelogram rule. I'm just pointing out these are very important. If you don't fully understand those, do recap, do revise that. Because we will be using the triangle rule here. So there's a river. And you want to get from point A to, well, as close to point B as possible. Because obviously you can see that the speed of the boat is smaller than the speed of the flow. So you would not be able to sail straight. You would not be, there's no way you can point the boat so you sail from A to B. And so what will happen is you will direct the boat something like that, and the stream will cause you to drift like this, and this is the speed of the boat, the velocity of the boat. This is the velocity of the water, and this is your resultant velocity. This is your resultant velocity. Well, yeah, let's just call it V. And if this happens, you will end up here. So the question is, which angle do you choose? What is the angle here? So that this point, C, is as close to B as possible. Well, if you use GeoGebra, you can actually play around with it a little bit. And you will see that if you make the angle, B smaller, if you make the angle theta smaller, you will the water stream is like this. So you will actually end up further. Yeah, you will end up traveling like this, and you will end up very far. If you make the angle bigger, if you make the angle like this, sorry, if you make the angle bigger, let's say if you point the boat in this direction, and the stream will cause you to drift sideways, you will end up also quite far. So you can clearly see that there is a sweet spot. Because if you keep increasing the angle, this would, so if you change this angle like this, for example, change like this vector goes like this, and this changes. If you keep fiddling around, you can actually solve this by trial and error. Oh, actually, you see, this doesn't change. So basically, this direction, this is the direction of the boat. This actually changes as a result of these changing. Okay. If you are entirely confused, please type 0. If you have absolutely no idea what's going on here. And okay. I think I need to explain a little bit more on this. So we are adding vectors. The velocity of the boat, the resultant velocity, is the velocity of the boat plus the velocity of the water. And this is here. So velocity of v, and this is b vw. Okay. This is the rule for adding vectors. So if you have vector A plus vector B is vector A plus B. So A, B, C. So vector C is equal to A plus B. A plus B. In a very similar way, the resultant velocity is the boat plus the water. So boat plus the speed of the water, the velocity of the water, gives you the resultant speed. Does it clarify things a little bit? Those of you who typed 0. Okay. So basically, what's going on here? So the velocity of the and you can see that if you change this angle, because this is the velocity that you choose. This is the thing you can control. Velocity of the boat, because you choose the direction of the boat. And I'm trying to show that if you change the velocity of the boat, this changes. This changes. And your task is to make this so that it meets the other basically this direction can change as a result. And your task is to make this as close as possible to C, as close as possible to B, sorry, which is, let's say, point C. Okay. So I'm going to redraw this. And this is the velocity of the water. It's quite big. Velocity of the water. Velocity of the water. Now the boat, which is 5, yeah, the velocity of the water is 5. The velocity of the boat is 2. Is it? They will be published in the group and they will be published on the website. Speed of the boat. So this is 5. Now, from here, you choose the direction in which the boat will travel. And the boat can travel in any direction, literally. The boat can travel in any direction, any direction. So what we do is we draw a circle of directions in which you can send the boat. This is a circle of radius 2. And the boat can travel in any direction within this circle. So let's say that the direction of the boat is like this. So the driver decides to point the boat in this way. Just one of the possibilities. This is the direction. This is the velocity of the boat relative to the water. Velocity of the boat relative to the water. So therefore, this would be the resultant velocity. This is the resultant velocity of the boat relative to the shore. And you can see that as you change velocity of the boat, this angle changes. Okay, this is a different angle. So I'll call it beta. As you choose a different direction, this angle changes. Your task is to make this angle, in this case, as big as possible. It doesn't matter where it started. I mean, okay, we can move this picture and say, okay, the boat started here. The boat started here. It's not the displacement of the boat, it's the speed of the boat. Your task is to make this angle as big as possible. And the biggest value for this angle is actually when it is a tangent. And when it is a tangent. Okay. And this is 90 degrees. Well, no, the answer is not 90 degrees. The answer is not 90 degrees. So this is 2. This is 5. And the question is, how should the driver direct the boat? So basically, your task is to find this angle. find this angle, and this will be, so this angle is arc cos. This is arc cos 2/5. So it's going to be 100 theta. Theta is, okay, let's keep it simple. Let's keep it simple because I use this angle. I use this angle. Theta is equal to arc cos 2/5, or inverse cosine. Arc cos 2/5, which is, wait a second, y2 is 7, sorry. The speed of the water flow is 7. The speed of the water flow is 7 and 2. So arc cos 2/7. And that is approximately 70, 73 degrees, 73.3 degrees. So the driver, so coming back to the initial diagram. No, it doesn't really matter. It could be miles, it could be knots. Oh, it's not, sorry. That is, of course, kilometers per hour. Need to be more attentive here. So theta is, this angle should be 73 degrees. This should be 73 degrees. And in that way, so this is 2. This is the speed of the boat. This is 73. 73. The river is 7. It's approximately like this. And the drift would go like this. So the boat will actually float like this and end up at point D. Point C. Sorry, point C is here. Point C. So quite a big drift. The actual so this is going to be 16.6 degrees, or 17 degrees. Now, if you were to increase this angle, 73, let's say you increase this angle, make it like this, then the river drifts you like this, and you can see that you will end up further downstream. You will end up further downstream. If you were to reduce this angle, let's use a light green color. If you were to reduce this angle, and the water drifts you water causes you to float like this. This would also cause you to drift even further downstream. So the 73 is the sweet spot for this question. But it is solved by this. So the river takes you this way, the engine takes you this way, and this is how you are actually moving. Right. If you have managed to solve it and get an answer, I mean, if you manage to solve the problem in the actual assignment, can you type 1 in the chat, please? Or if you were halfway, type 0.5. I don't know. Oh, so quite a few. Okay, so you managed to. Okay, it's good. It's good. It's good to hear. Okay, well done. Well, okay, that's pretty much what we have time for. Didn't have time to return to question 7, but it's very similar to what we had before. And I'll just a few more words about this. Small airplanes, 60, so you can't. This is not a good idea. You need to fly like this, and these are crosswind landings are quite spectacular. If you just go on YouTube and find crosswind landings, they are they're very beautiful to watch. Now there's a lot of things to think about as you watch the plane approach at a not in a straight line, but it actually goes sideways, and this is what's going on. The plane is like this, and you need to point the plane. Okay, so you need to just lock this, lock to background. So you need to point the plane this way. You need to point the plane this way in order for it to actually follow a straight line path. So we call this the velocity of the wind. This is the velocity. This is well, it's called the airspeed. And this is the ground speed. The ground. All right. So yes, thank you for listening today. The deadline for the assignment is Monday. As far as I understand, yes, Monday is the last day. So make sure you submit your assignment by the end of Monday. If you've made the assignment better, you can submit a second version of the assignment. So you just submit assignment version 2. Make sure to indicate your name in the name of the file and inside the document as well. So make sure you do that. Right. Okay. Thank you. Oh, I drew the board. Yes. We come up. Did you come up with the idea with the circle? It's a famous problem. It's a problem from my time at school. So can you send the board again? Board is this. I'll send the board to Telegram as well. So make sure you subscribe to the Telegram chat. Unmute the notifications so you don't have to go through. Doesn't buzz all the time. And yes, make sure to check your emails. All right. Okay, well done. Have a great evening, and I'll see you. Send the Telegram group chat. All right. There was a link sent. Just give me a moment. If you don't have the Telegram chat, I will find it. Just a moment. I think it is. Yes. Okay. I will send the link to the Telegram group. Yes, everyone is free to go unless you want to stay for the Telegram link. This is the Telegram group. Okay, the solution submitted. I would need to write. Yes, but please make a PDF. If you're unsure how to make a PDF from pictures, Google is your friend. Potentially, you could put the pictures into a Word document and then save as PDF. I'm sure there are much better ways to do it. There, if you have a cam scanner, if you download a cam scanner on your phone, it allows you to scan to PDF right away. But of course, scanned is preferred rather than pictures. Confirmation email is that something you sent me? Hassan, oh Hassan, yes, I got your email. Okay, I'll see what you can do. I'll see what I can do, but just make sure you have the email address to send the work. Yeah. So Hassan, I will. Yes. So just make sure you send it, and I will make sure that you. I will just forward this to admin. All right. Okay. All right. See you, everyone. Bye. Just wondering what level does this cover throughout the topics? Well, the level of difficulty would be quite similar. So the level of difficulty quite similar all through we'll have 12 topics in physics and 12 topics in maths. So yes, which would be quite similar to what we are. Um, college uni. What is this? Well, look, there are no new topics. These are things you do in school. It's just things covered in a slightly deeper level. I mean, we're not we're not doing any new topics. Dot product is in is in A levels, and vectors are in A levels. It's just the way we use vectors. It's slightly different, slightly more sophisticated. Well, okay. Typically, you would do questions like this at university, but there's nothing stopping you from doing it. Okay. Right. See you, everyone.